So hi, in this video I'm going to go over a filter for picture lab that averages the colors that are found in a set of 9 pixel objects and sets all those 9 pixel objects to have the same color, the average of the colors that are in those 9 places. Okay, so let's take a look at this. So here's the result. As you can see, this really pixelates the image. Here's the original image. Here's the image where I've averaged. And if we zoom in on this, you can really see that represents 9 pixels in this image that have been averaged to that one color. Okay, so let's take a look at how I accomplish this. So we do the standard two-dimensional array by calling the picture class is getPixels2D. This is a two-dimensional array of pixel objects. We get the width and the length of that two-dimensional array. And now we have the standard nested loops. You'll notice here I'm going from I'm starting one column over one row down from the top and one column over from the left, and I'm going by 3s, right? Because the first time because I'm doing this block of 9 contiguous pixels, that's why I'm jumping over 3 to get in the center and down by 3 to get in the center of the next contiguous block of 9 pixels. All right. Now I have an array list here called pixel group. It's an array list of pixels, and I'm just going to, as I collect the pixels that are within that group, I add them to the array list. Now all of these if statements are to handle the situation where I might be over at the right side of the image or at the bottom of the image, and I might not have 9 contiguous pixels because some of the pixels are outside that I would want to look at. Positions that I would look at are outside the bounds of the picture, right? So I'm just using some if statements here to make sure that I am in fact, this would be the bottom right pixel, make sure that that's inside the dimensions of the two-dimensional array, which is the number of pixels, the width and length of the picture really. And if it is, I add that pixel to the array list, and so on with these if statements, right? And these two, and again, these all just come into play when you're over on the right side of the image or on the bottom, very bottom of the image. And when I say image, I mean the two-dimensional array of pixel objects that represent the image. Now these I know will exist because they are above, they are at and above and to the left of the center pixel of the 9 pixels. Okay. So in most cases, I will have added 9 pixels here, but over on the right and down at the bottom, it will be less. But at any rate, the number of pixels added I can easily find by just getting the size of the array list. Right? So now I come down here and I set red, blue, and green integer variables to 0. Then I use a for each loop, right, to go through the array list. So one at a time, a pixel will be a reference to a pixel, all the pixels in pixel group. And so I'm averaging up the red values and the blue values and the green values. And then I'm dividing whatever I get by pixel group.size, the number of elements in that array list, which is going to be 9 in most cases, but not always. Then I make a new color object using those average red, blue, and green values. Then I update the pixels to that average. So I'm setting their color to the new color. And again, I have to make sure that those pixels are actually, those positions are within the two-dimensional array. And so I'm checking here, I can't obviously do that if I'm on the bottom row or the rightmost row, because there won't be anything to the right or anything to the bottom. So again, that's what those if statements are about. These I know exist because they're above and to the left and exactly at the center. And that is how this thing works, right? So, you could easily change this to do blur more pixels if you wanted to. A fun exercise might be one where you can specify the size of the box, square pixels that you want to average, and then it would work no matter size, no matter what size you gave. That could be fun to play with. So that is another blur filter, and we're going to look at one more in the next video. Thanks.